In this section, we are going to talk about the memory design. We said the CPU modules is consist of the CPU and the memory. So memory actually the size of the or the memory usually used to store the information and the software or program of the PLC in addition to the data that received from the CPU. I mean from the input devices. So the size of memory here, as you can see here, the size of memory for the PLC is not like the size of memory for the personal computer or for the laptops, because for the PLC we do not have a lot of applications running on the PLC system. We only have one application or one system which is run continuously. So we do not need to use a memory with gigabyte. We only talk about the kilobyte or uh, up to megabyte here. So we can see here the size of memory actually depends on two main things. One is the number of input and output that will be connected to the PLC system. The other is the how the program that we are going to use to control the process is complex, or how what is the complexity of the program that we are going to use to perform the control of a process. So in terms of the number of input and output here, we can see we can use up to 1K or 1 kilobyte with the micro logic here, 1000 controller. It use 1 kilobyte memory, which support up to 20 input. That means I can connect 20 inputs, like 20 sensors or 20 switch to the BLC or to the CPU, to the BLC unit, to the BLC system, and output up to 14 outputs. So if you have 20 inputs, 14 output, you can use the 1 kilobyte memory. For the 64 memory here, it's which is usually used with the SLC 500 controller. It support up to 4096 inputs and outputs. So for the 32 mega, which is usually used with the control logics controller, which is the biggest size of a PLC system, controller. Actually, the memory can be changed from or varies from two or selected between 2 mega to 32 megabyte, and this memory actually support up to 1000 or 128,000 inputs and outputs. Uh, so this is how we can. I mean, it depends. If the PLC system is small, we use 1K. If the medium, we use 64K. Big, we use either 2, 4, 8, 16, up to 32 megabyte. Usually, the memory location actually we inside the memory. The memory refers to the address that we mentioned before. We said there is address for the input output devices, and this address will be reflected in the place or in the slots inside the memory. So it will be represented here by bits. So each place in the memory represent by 1 bit here. So 8 bits represent 1 byte and 16-bit represent 1 word. So, or we may have 16-bit or 32-bit or 64 bits. So it represents just 1 word, or word of 16 or word of 32. So this is how the slots are represented. Each of these bits can be connected or can be indicate the address for or the status of one input discrete device. When we talk about the discrete device, we need only 1 bit to represent it. So if the input is discrete device, we need 1 bit. But if the input is analog device or the output is analog device, so we are going to talk about the word in that case. So the program inside the memory usually stored in the form of ones and zeros. So you can see here, this is 0, 0, 0, 1, 1, 0, 0, and so on. So typically these ones and zero, a set of ones, or a set of bits, as we said, 8 bits represent 1 byte and 16 bits represent 6 word. Okay. Section of memory used to store the status of input called input status. So the input status here is the input. We have the input models connect with the input devices. Inside the memory, we have a part we call it the input image table here. This input image table represent or reflect the status of the input models. So, for example, if we have this one slot here, and this one slot connect to two inputs, two switch input devices, each switch will be represented since the switch are discrete, and this is input will be discrete input models. So each of these devices will be represented by one bit inside the memory. So if we set the first line here, represent the slot, this slot actually from 0 to 6 to 15, which represent by 16 terminals here. This, if you count it, is a 16 terminal from 0 to 15. So in the bit number one, you can see here this bit number one is connected or is equal to 1, while the bit number the first, this is 0, 1, 2, 3, 4, 5, 6, 7, 8. In the bit number 8 is connected here to the terminal. This will be come from number 8 terminal. So the status of this one is 0, while the status of this one is 1, because this is closed and this one is open. Depends on the input device. So the input status here, input status file or input image table reflect the status of the device that connected to the input module. As you can see here, this is the software that we have, or the simulator, to simulate the status of this switch. So you can see when the switch is off or on, the status of the bit will be changed. Again, we can repeat this. So the first, this one is switch number one. This is 1 1. So 1 1 is here. This one is represented 1. And the second one is there is number 8, which is 1 and 0, 1 and 0. So based on the status of the instruction, which is reflect the status of the real devices, it will show the bit. Is it 0 or 1? The second, also there is another section which of the memory which is reflect the status of the output file or of the output devices. So we call it output model or output file image, output image table here. And also the same, if we say this is slot, this one is slot represented by this slot, depends on actually the slot number. Maybe we have 10 slots, so each slot will be represented by one row here of bits. Okay, if the slots, if the model here is consist of 8 bits, this will be 8. If it consists of 16 bits, so this will be 16. Okay, so here we have, this is the output state, connect to the output model or the output devices here. We have one device is output is off, one is on. So the off one here will be represented by its status will be 0 inside the memory, and the on one here will be the status will be 1. That means the controller send switch on command to the device connected to this bit and switch off command to the device connected to that bit. We can see here, this is the output. You can see the status here change from 1 to 0, from 1 to 0, and this is for output 2 is here. Also the status is changed from 1 to 0, 1 to 0, and so on. So usually the status of the device will be reflected in the table or the output table or input table of our memory.